This question is x minus 2 over x squared minus 9 is less than or equal to 0. So my usual strategy is to solve it first as an equal. X minus 2 over x squared minus 9 equals 0. When does a fraction equal 0? Well, you'll recognize that 0 over 5 is 0 because 0 times 5 is 0. A fraction equals 0 in the numerator when the top is 0. So this is true when x minus 2 is 0, when x equals 2. So when I lay out my number line, when time comes to do that, when I'm at 2, it's less than or equal to, it equals 0 when x equals 2. That will be a solid dot. I just want to make that note. However, we also recognize that the bottom cannot be 0. Division by 0 is always a problem. If you have 3 divided by 0 equals something, you would need something times 0 equals 3. And nothing ever works that way. So division by 0 is not acceptable. That is not in the domain. So x squared minus 9 cannot be 0. So well, let's find out when it is. When does x squared minus 9 equal 0? Well, we factor that. That's x minus 3x plus 3. So that means x minus 3 is 0 or x plus 3 is 0. So we get x is 3 or x is negative 3, but it cannot be. Those numbers are not in the domain. They are not allowed. You cannot have a division by 0. So as I mentioned, we're going to lay out the number line. 2 is a solid dot because it's less than or equal to 0. Then my 2 points that are not in the domain are 3, but that's an open dot because, again, that is not even allowed, and negative 3, clearly not to scale. And we're going to need to work off of this interval, these 1, 2, 3, 4 intervals, testing our numbers and seeing how they behave. So let's jump to another page now that we have these points. So we know what our question is, x minus 2 over x squared minus 9 less than or equal to 0. Laying out our number line, here's negative 3. That's an open circle. Here's 2, solid, because again, less equal to, and that makes the entire fraction 0, and 3, open. And we have to choose numbers in each interval. I always put in 0 first if I can. Between negative 3 and 2 is 0. Between 2 and 3 is 2.5, 5 halves. That's unpleasant. Beyond 3, I'll choose 4. And to the left of negative 3, I will choose negative 4. Now, I think I'm going to use the graphing calculator to help me do this, but let me go ahead and check 0 myself, because that's relatively easy to do. If I plug in 0, x minus 2, 0 minus 2 over 0 squared minus 9, is that less than or equal to 0? Negative 2 over negative 9, is that less than or equal to 0? Is 2/9 less than or equal to 0? That's no. So I do not shade that interval. Maybe I'll do negative 4 as well. I guess this isn't so difficult to do. Negative 4 minus 2 over negative 4 squared minus 9. Negative 4 minus 2 is negative 6. Negative 4 squared is 16 minus 9. 16 minus 9 is 7, so we get negative 6/7. Is that less than or equal to 0? Is negative 6/7 less than or equal to 0? That's yes. So I am going to shade this way. Beyond 3 is 4. Well, sure, let's go ahead and do that one. 4 minus 2 over 4 squared minus 9 less equals 0. 4 minus 2 is 2. 16 minus 9 is 2/7 less equals 0. No. 5 halves, that's going to be kind of a hassle to do. So it would have to be 5 halves minus 2 over 5/2 squared minus 9. We want to see, is that less than or equal to 0? So like I said, I think I'm going to go ahead and pull up my calculator to show you how I would do that. So let's do it. So I want to take 5/2 minus 2 upstairs. Divided by parentheses 5/2 squared minus 9. So the order of operations here gets tricky. So I'm going to show you another way here in a minute. And what do I get? I get negative 0.18, which is what is a fraction. If I want to check that, change that to a fraction. It's negative 2/11. So I get negative 2/11, and that is less than or equal to 0, so I do shade that one. So before I jump back to the calculator and show how I would plug all of these numbers in to make my life a little easier, we will see what our final answer is. This first interval is from -infinity to -3, round bracket, union, no here, yes here, square bracket 2 to 3. Square bracket 2 to 3, round bracket. But let's do a couple things here. Let's take a look at how we can evaluate the -4, the 0, the 5/2, and the 4 more quickly using the graphing calculator. So what I'm going to do is I'm going to plug in x minus 2 over x squared minus 9 into my function. Watch your order of operations. X minus 2 divided by parentheses x squared minus 9. So that is my function. I want to go ahead and create a table, second table set. Make sure it's on ask. If it were on auto, second table, it looks something like this. But I want to do it on ask. So second table set, take it down to ask for the independent variable. Then go to second table and plug in the numbers. When I plugged in -4, I received -6/7, which was less than 0. That was a yes. Notice -0.8571 looks a lot like -6/7. When I plugged in 0, I received 2/9, which was not less than 0. That's why that was a no. 2/9, 0.2222, so that would be a no, not less than 0. When I plugged in 5/2, remember that was kind of a hassle. 5 divided by 2, it's easy here. Is the result less than or equal to 0? The answer is yes, -0.1818. So we assume that's -2/11. When I plugged in 4, I received 2/7 before, which is 2.857. And sure enough, that is not less than 0. So the -4 interval was correct. That corresponded to infinity to -3. And the 2.5 interval was correct from 2 to 3, which again is why our answer looked like this. Well, can we look at the graph solely and determine what the solution is? So I have the function in my calculator already. If I go to zoom decimal, that might be good to start with. And I want to see, when is this less than or equal to 0? There it is. There it's not. Now it is. So on what intervals is it less than 0? From here to here. So what is that? -infinity to -3. You see that? The function is below 0. Where else is it less than or equal to 0? Not here, until it gets, boom, until it gets to here. But from 2 to 3, it looks like it's less than or equal to 0. And then beyond 3, it isn't. So we see our intervals below -infinity to -3 together with 2 to 3, which also agrees with what we said before. So, try to do this using algebraic techniques first, and then make sure you check your answers by looking at the graph.